Welcome to our lecture on microphones. The best part of recording, one of the most enjoyable parts for me anyway, is working with microphones. To me, that's sort of a lot of the essence of recording is that particular act. You've probably seen some microphones. You're probably at least passingly familiar with certain microphones that you've seen, and the ones that you've seen the most are those Shure 57s and 58s that you see on stage, or see rock and roll musicians or even jazz musicians, hip hop musicians, the microphones that you see them usually on stage, working the stage with, 58 usually. And those are great microphones. Those can be used for all sorts of different things. They're great for that particular thing, which is going out on stage and being on a stage with a lot of loud other instruments, because these microphones are very directional. They're dynamic and they won't feed back as easily as other microphones will. So there's lots of reasons. But anyways, let's talk about the different kinds of microphones. And it's kind of cool that we even have microphones at all, because all of this really started in the beginning with the recording, with getting together and yelling into a tube and just playing in front of a big cone. And that cone sort of all ended up at the end of a line where it was then attached to a stylus, which then cut the disc. I mean, you recorded directly to disc back then. I mean, not the way we do now, directly to disc with a cutting stylus. Needless to say, we didn't get a lot of great frequency response from that. This was mixing here when you had all these people gathered around in front of a cone. We have to do a better job of capturing audio events in the air, the compressions and rarefactions in the air. How can we capture those? And the best way we know that we can capture them in some way is to have some sort of a diaphragm, some sort of a surface that those sound waves hit up against, and then we've got to figure out some way to take that activity of that hitting that diaphragm and turning that hitting the diaphragm into an electrical signal. As we've found out earlier, these compressions and rarefactions in air can find their analog as voltages in alternating current. Whatever we get the microphone find is exactly what we can have in our electrical line, which we then can then send to a recording device like a disc cutting machine, or later on, of course, a tape machine. We have to figure out what kind of a technology we're going to use to get that transfer of energy to happen. Of course, everything when it comes to microphones and audio starts with telephones and starts with Alexander Graham Bell and the beginning of Bell Labs. The necessity to be able to speak into a device and it be heard, miles and miles and miles away somehow through electrical induction. And so the first microphones were carbon microphones. You had your diaphragm up front, and then the diaphragm was attached to a little plate which pushed against a bunch of carbon granules. And there was already a circuit there with a slight charge from a battery, and then the fluctuation of the diaphragm hitting those carbon granules caused fluctuations in the voltages of the circuit, and that translated into an electric waveform that then can become an acoustic waveform coming out of a speaker. They didn't have very good frequency response. They're very narrow, but they're also extremely durable, and that's pretty much what you would find in your old handset telephones back in the day. Needless to say, we had to do better than that for music, because if you've ever heard music listened to through one of those telephone systems, it's not very good. We end up trying to get better frequency response to get it to the point where we could possibly record sounds between 20 hertz and 20,000 hertz, which is our audio window for listening to stuff. And music and anything that we would really want to hear has to sort of fill that range. The microphones that we started looking at making, the first one was the condenser microphone. And E.C. Wendt is the inventor of the condenser microphone. So the idea of the condenser microphone is that, again, you have a diaphragm which captures the sound waves from the air. The compressions and rarefactions bump up against this diaphragm. There's a charged backing that is not attached to it, but is a little further apart from it. And then the capacitance that happens between that charged plate and the diaphragm, those fluctuations in capacitance then goes to a transformer, which then inverts it into a low voltage fluctuation, because capacitance is inverted to voltage. That's then sent to a head amplifier and then out of the microphone. What this requires, of course, is that there has to be power for that back plate. So we can either use a battery, or we can use what we call phantom power, which we can send from our recording device, 48 volts, or we can have an electret already pre-charged backing plate, and which we'll see that in a lot of microphones that are built into devices. So that was the condenser microphone, and those early ones didn't sound great. In 1916, they were just getting started with this technology, didn't really quite have the right materials for this, had the right idea, but there was still a lot of things to work out. And when they did work it out, it was worked out by the guy that was considered the master of the condenser microphone, a gentleman by the name of Georg Neumann. He was a German engineer. He had started actually his microphone business near the end of the war. The Germans had the best microphones. It was amazing how good their stuff sounded compared to the Americans back in the days with their broadcasts. Neumann had really gone forward to the designs for condenser microphones, building these special tube amplification units that went with them. He created the first CMV3 bottle, which you've seen probably some copies of, those of you who are microphone aficionados. That's the first one, and that has that sort of distinctive little diaphragm popped up like a periscope above it. Later developments from Neumann were the U47 and U87, and we still use these microphones whenever we can. And if we can actually find these original microphones, they go for top dollar, and they're extremely well made, and they sound fantastic. They're still the gold standard. Still haven't really improved on that technology since the late 40s and early 50s. And that kind of brings us to just sort of talking a little bit about polar patterns. Different microphones have different ways of looking at the sound. If you just have your basic diaphragm open to one area without any backing to it, you'll find yourself with what we would call an omnidirectional microphone. In other words, it will get equal coverage of sound from all areas around that surface. If we open up that back plate and we have it be bidirectional, then all of a sudden this gives us the opportunity for what we call the figure eight pattern. So we would get sound coming on one side and the other side. Then we have the cardioid. And cardioid pretty much is what we can get if we take an omni and we add it to a figure eight. Now, if we really wanted to do that, we'd need two diaphragms to do that. But the best way we can do this actually is to do the figure eight pattern with the bidirectional microphone with our diaphragm open on both sides to the sound. And if we take one end of that sound and we create a series of acoustic labyrinths back there and create it so that the sounds come to the other side of the diaphragm out of phase at different times with different frequency ranges, we can then sort of turn our figure eight pattern into the cardioid pattern, which is a directional pattern which sees what's in front of it and rejects what's behind it. Just to reiterate, the omni pattern is derived from what we call a pressure mic, a one-sided diaphragm exposed in the front, completely enclosed in the rear, and so it will only respond to the changes of air pressure created by the sound waves. So this will be a clear, uncolored ambient capture. The figure eight would be what we call a pressure gradient mic, usually a ribbon mic, where the diaphragm is exposed to the front and the back. There's a difference in pressure between the front and the back. The cardioid, again, mathematically is sum of the omni and the figure eight. And this is achieved by a diaphragm exposed on one side and the other side also exposed, but with a series of acoustic labyrinths. And the sounds reach the back with changes in phase and amplitudes, and this allows us to get the directional response. And we can actually achieve all of these with the AKG C414 because it has dual diaphragms, and this will, if we put the front diaphragm out of phase with the back diaphragm, that's how we can create the figure eight. If we have them in phase with each other, we can create the omni. So we can sort of trick ourselves into getting an omni microphone and a figure eight using two diaphragms if we want to. We also see we have a couple of other cardioid possibilities, the supercardioid and the hypercardioid. And these particular cardioid patterns give us more unidirectionality and focus, like these are used with shotgun mics, for instance, but they also create lobes behind them. In order to achieve this directionality, we have to sacrifice and get these lobes back behind it. And if we're okay with that, if we can sort of set our microphones properly for that, then that's just right. So supercardioid, hypercardioid, those are two sort of variations on cardioid that we can use. So speaking of omni mics, what do we have for omni mics actually at the studio? At the Haas Media Studio, we have the AKG C414, which again gives us multiple polar patterns and does this by having dual diaphragms. We have our Audio-Technica 4050, and it has a setting on it that can go into Omni, which is nice. We have our Neumann U87, and that has a feature where we can go into Omni and figure 8. We also have a couple of lavaliers, our Sennheiser ME22s. And also, we have a pair of Schoeps CMC 6Us with our MK5 heads, and those can go either Omni or cardioid. On top of that, we have a Sennheiser Ambio, which can become any kind of polar pattern we want, but it's also an ambisonic microphone, and it can give us 4 channels and allows us to do actually first-order ambisonics. We won't get into that quite yet. Around 1920 or so, around the time that the condenser microphone was invented, Harry Olson came up with the ribbon microphone. And we have the Royer 121 ribbon microphone in our studio. But the ribbon is a whole different thing. It's a bi-directional microphone. It gives us a figure 8 pattern. The ribbon itself is open on both sides of the ribbon. A corrugated piece of ribbon, of metal ribbon, it's an aluminum strip, suspended in a magnetic field. And it's attached by non-conductive baffle mounts. And some of these ribbons are made with plastic polymers or gold-coated or whatever. The thing that's interesting about the ribbon is it's both a diaphragm and a conductor. And as a diaphragm, it moves according to the sound pressure variance. So as compressions and rarefactions in the air hit the microphone, that moves in the magnetic field. And then as a conductor, it's moving through the magnetic field and it's inducing a voltage across itself while it does so, and because it's suspended in this enormous magnet. So then that hits a very small step-up transformer, brings the voltage up, brings the impedance up a little bit. These microphones require a lot of amplification, fairly quiet, and have pretty low voltage outputs. But they also have really smooth high-end response and roll-off, great transient response, and really good proximity effect and directionality. And they became the prevalent microphone for the crooners. And Frank Sinatra, Bing Crosby used these microphones. And they had this really smooth upper end response, very warm and intimate, and they could sing very sweetly and closely into these rather than singing loud and doing the vaudeville act stuff like Al Jolson did. The ribbon is a bidirectional figure 8 microphone, so it's getting information from the front and the back of it at the same time. It became a necessity over time as people were using microphones more and more to have our microphones have more directionality. Omni mics, we're capturing too much stuff. We couldn't get more specific, couldn't get close to something. The ribbon mic did a little bit better, but we still had that back side. It was still getting sound from both the front and the back. What if we just wanted to get it from the front? Some problems with getting directionality. So the Marconi Sykes magnetophone was the first dynamic mic. And the whole idea of the dynamic mic now was that we had a diaphragm again, have to have a diaphragm. Compressions and rarefactions of the air hit the diaphragm. The diaphragm is attached to a moving coil, and that coil surrounds a magnet. And as the coil moves against the magnet, once again, we have fluctuations in voltage. Those fluctuations in voltage hit a transformer and then come out as a voltage that we can then go to a mic preamp and amplify into a signal. Because the diaphragm is attached to a moving coil, it takes a little bit more transient action to move that diaphragm. It's less sensitive to transients. That actually almost acts a little bit as a compressor, because we're talking about moving something up against a magnet, the act of moving that diaphragm, whereas on the condenser mic, we're just sort of hitting the diaphragm and changing a fluctuation in capacitance. With the dynamic, we are physically moving the coil against the magnet, and that act makes the dynamic microphone, number one, a little bit less sensitive, makes it so that it can also handle a lot more high SPL, high volume events. Dynamic mics are great for drums, of course, and they're great for those microphones that you see musicians on stage with. Those microphones take a lot of yelling, they get dropped a lot, sometimes even roadies use them to hammer nails into the wall. Dynamic mics are good for that. And we have several at our studio as well, the EV RE20 being sort of probably the most popular one, the SM58, the SM57. Those are great microphones and all-purpose microphones being used by many people all over the world. Also great about a dynamic microphone, though, is also it does not require power. It doesn't require phantom power. You plug it into the mic preamp and it works. Same with the ribbon. You don't need phantom power for the ribbon. In fact, you can't use phantom power on a ribbon. You might actually break it if you do that. So keep the phantom power away from the ribbon whenever possible. We have hypercardioids we can talk about. Those are usually shotgun mics, more directional. The AT-BP 4029 is probably the most popular shotgun mic you'll find around here. There's also other microphones to talk about. I mean, we've talked about those main three, and I would say probably 95% of the microphones you'll be using in any kind of recording situation will be the dynamic, the condenser, or the ribbon. But we also have piezoelectric or piezoelectric. I'm never quite sure exactly how to say that. I think it's maybe piezo. Actually, they rely on crystals that when pressure is applied to these crystals, they emit electric signal. And so these are usually contact microphones, like violinists that have contact microphones that are attached to their violins. They're usually piezo, and they'll take the vibration straight from the instrument quite a bit, as well as the acoustic vibrations in the near area. We also have boundary microphones like the PZM, and these are really interesting microphones because they capture the first reflection. If you put a PZM up somewhere, and it's a flat boundary with a microphone that's attached, and the microphone is looking right at the point where the sound hits the boundary. And you get a very interesting thing that happens with recording at that point. We also have some other microphones like the electric condensers, and these are condensers that don't require a charge from phantom power, built-in charged backplates. And these can be miniaturized, and often these are the microphones that you'll find in your computer and in your phone. MEMS are really interesting microphones that use acoustic sensors fabricated onto semiconductor production lines with silicon wafers. They can be miniaturized and be almost any size. And then fiber optic microphones. These are super cool. It's diaphragm, and on the surface there is a fiber optic light source which bounces at that diaphragm, and fluctuations in that diaphragm cause, of course, the light to bounce differently off of it, and that is then translated into an audio signal. For our purposes, most of our microphones are going to be condensers, dynamics, ribbons, and our polar patterns are going to be omni, which means we'll be getting all directions around the microphone all the time. Figure 8, which means we get in front of the microphone and behind it, and we get rejection from the sides. And this is one of the key things about our figure 8 ribbon microphones, is that we can get those in position where they reject stuff from the sides. When we have multiple instruments recording, that can be a really beneficial thing to use sometimes. And then we have cardioids, and we have several different cardioid polar patterns, but those are our directional patterns that allow us to get a microphone and to get something specific and reject things from behind it. So let's talk about our microphones that we have in our studio. If you're curious about knowing more about the microphones that will be available to you once you come back to school, and yes, we will do our best to make these available to you when you come back to school. We have 4 AKG 414s, and these are the new ones. These have multi-patterns. These give us cardioid, figure 8, and omni. They're sort of our workhorse microphones, what I call the vanilla mic. They go with everything. They can be used for vocals. They're good for drums. They're really good all-purpose condenser mics. We have a couple of these AKG P170s, little cardioid guys. They're okay. I would use maybe one for underneath the snare drum. We have one Audio-Technica 4050, again a multi-pattern microphone. This has a nice warm characteristic to it. I would say it has good bass response. It can be used for vocals, it can be used for guitars. It has a certain kind of response that I think some of you might find just right for you. Good low-end response. Our Neumann U87. Now this is our most expensive microphone of the group, and it can do figure 8, cardioid, and omni. It would probably be used for vocals, for special occasion kind of stuff. It's one of our more high quality microphones. It has great sensitivity, really good frequency response. We have a couple of Neumann KM184s. These are cardioid little guys. These are great for acoustic instruments. Pretty good for drums, but they have a really good high-end response. Really good all-around microphones. We have a pair of Schoeps CMC6U with MK5 heads, which can do either omni or cardioid. And these are really super high quality microphones for overheads, for pianos. These are really clear, very clean, full frequency response. Acoustic guitars, pianos, not so good for vocals, actually. We have a couple of Shure KSM32s, which are some really decent cardioid microphones, some high-end Shure microphones, and they're pretty good. They have some funny qualities to them. And then we have a couple of these Shure PGA81s, which are cardioids. We have a Shure drum kit that we got, which has all these microphones that are just for drums. And so we have a couple of condensers that come with it. Most of them are dynamics. Some of these microphones are pretty cool. If you come to campus and want to record some drums, you might actually pull this little microphone kit out and have some fun with it. It's pretty decent. So those are our condenser mics that we have available to you at our Haas Media Studio. Then we have our dynamics. We have an AKG D112, which is great for kick drums. You may have seen it, sort of an egg-shaped thing, large diaphragm, great for low-end kick drums, perfect. We have an EV Electro Voice RE20. These are great for vocals, but these are also great for kick drums. These are larger microphones. I like them for bass amps. They're great for that. Also good for guitar amps. Have a certain sort of quality you might find useful. Decent vocal mic. Then we have our redoubtable Shure SM58s and SM57s, 258s and 557s. 57s are great for snares and guitar amps, pretty good for tom-toms. The 58s, hard to say what you might want to use those for. I'd probably use them for scratch vocals in the studio. PGA 56, PGA 57, PGA 52. These are all components of our Shure drum mic kit that we have. We have this crazy SM53, which, I don't know, it's sort of a weird mic. Don't know if that's useful. An AKG D9000, which is another one of those microphones that we just sort of have. And then we have these Sennheiser E825Ss. Again, these microphones are just kind of cheap microphones. You might want to try one of these out for just do something crazy. We have a couple of specialty microphones I need to talk about real quick. We do have a ribbon microphone, a Royer 121. Be careful with it. Don't hit it with a lot of SPLs. And just really sort of baby this microphone. Don't manhandle it or woman handle it too much. We have our Sennheiser Ambio, as I mentioned earlier, which gives us a first order ambisonic, but also we can parlay that into any polar pattern as well as 4-channel first order ambisonic. And then we have some lavaliers, which give us a bunch of omnis. We can then sort of clip those to our shirts. They're also pretty cool to use suspended in an acoustic guitar. Some notes about microphones I thought I'd share with you. Omnidirectional mics, you should put them close to the sound source because they will pick up all ambience around it. So if you're really trying to get just what you're trying to record, get it as close as possible to it. They will pick up ambience, but they also will give you a lot more frequency range, oddly enough. That's a beautiful thing about an Omni. Ribbon mics, we call them bidirectional, but they're still pretty directional. If you're singing in front of the ribbon mic, of the bidirectional mic, and someone's on the other side of it sort of going, you're going to really hear mostly the stuff that's the loudest stuff that's hitting that microphone on the front, whatever side of it it's happening at. Side rejection is great on a ribbon, and that's why you might find that useful. Dynamic mics require the sound to move a mass, the diaphragm and coil, so this doesn't happen instantaneously. It does take a millisecond or even less than that to just get it off the dime to move. So that gives us just a little extra edge for high SPL sources like drums. That's why we put dynamic microphones on drums and loud electric guitars. Piezoelectric or piezoelectrics are the microphone of choice for contact mics, very directional, lots of high-end frequencies with those. And condensers, the thing about condenser microphones you always have to remember is that they need some sort of a power. It needs either a battery or phantom power. 48 plus volt button that you see on your console or your preamp will activate the condenser mic, and you have to make sure that's on for your condenser mic to work. Dynamics don't need that. Ribbons don't need that either. So that kind of gives you a little bit of overview about microphones. Hopefully that sort of helps you going forward as we do some experiments with mics. Most of you should have at least one microphone in your possession by now. If not, then the only microphone you can possibly use is the microphone on your computer. I'd like to go ahead and just encourage you to find a way to have some sort of a microphone available to do at least some of the microphone experiments. And we do have a microphone lab that we'll probably need one for anyway. So it's a good idea to have a microphone though. And if you are thinking about buying a microphone and you want to have some advice, you're more than welcome to reach out to me through WebEx or by email, and I'll be more than happy to advise you with any sort of thing like that. Best microphones for the price. Hopefully this helps you understand microphones better, and I'll see you soon. Take care.